So today we're going to go over the day 7 lesson on residuals. This is a fairly simple lesson, so this should be a quick one. First of all, residuals talk about how close data is to your linear model. And what we did in this lesson is we calculated and plotted residuals for a given data set, and then used the information to determine the goodness of fit for a linear model. So we're going to talk about these things as well. So first of all, a residual, or when we talk about residuals, they're the difference between the y value for a point in a scatter plot and the value predicted by the linear model for that x value. What that means is if you take a look at this, we have our linear model, and then each of these points is somewhere close to it. So in the scatter plot showing the length of fish and the age of the fish, the residual for the fish who is 2 years old and 100 millimeters long is 8.06 because the point is at 100, and the linear function, if you put 2 into this function right here, it gives you 91.94. So 100 millimeters minus 91.94, that gives us our residual. That's how different it is from what our linear model predicts. So that means that the actual fish is about 8 millimeters longer than our linear model estimates for that same age. Now, finally, when a point is above the line, you always take the y coordinate for your point and then subtract what it would have been for your linear model. But when it's above the line, we end up with a positive residual, because obviously you're going to have a bigger number minus a smaller number. But when the point on the scatter plot is below the line, we still take this y value minus what was predicted. So a smaller number minus a bigger number would give us a negative value. A line that has smaller residuals would be more likely to produce estimates that are close to the actual value. So what a small residual means is that the point is really close to your linear model. So these ones have pretty small residuals. So does that one right there. And as we can see, all of our residuals for this particular model are going to be fairly small. So let's take a look at the cooldown. Each of these graphs of residuals is from the same set of data using different lines to fit the data. So each of these points represents how far off the linear model your actual measurements are. So if we look at this right here, when x is 1, whatever x is, we have two different y values here. One of them has a residual of 0. That's going to be right on our linear model. This one has a residual of positive 1/2, which means that that point would be a half above your linear model. These down here would be below your linear model. Now, remember what I said. The better the fit your line is, the smaller your residuals are, because the points are closer to the line. So, as you're looking at this, which graph is most likely to represent the residuals from the best fit line? Again, the best fit line would have the smallest residuals. So looking at the 4 charts, look for the ones that have the smallest residuals. The other thing is, if it's a best fit line, you should probably have about the same number of positive residuals as negative residuals. Since these are all 0 or negative, what this tells me is that my linear model is actually above every single point, and that's not a very good model. Anyway, if you have questions, let me know. I'm here to help.